Hi Year 12s, right, I left you with 3 questions to look at for homework on the sheet that we didn't quite finish in class. Okay, what I'm going to do is going to go through those 3, each part separately in different videos, so you can see where I'm going to get the answers from. Okay, the first question says that you've got 2 particles, particle A and particle B. Particle A is 0.4 kilograms, particle B is 0.8 kilograms. They are connected by a light and extensible string. Particle A is 4.5 meters away from a pulley. The string passes over the pulley and is taut. Okay, so there's a number of things that tells us. That tells us light and extensible, it's got no mass. It also means the tension is the same throughout the system. The fact that it's taut means that the acceleration is also the same throughout the system. You're told that the particle A is 4.5 metres away from that pulley. You're also told that particle B is 0.5 metres away from the ground. Okay, you're told there is a force of 0.08 G working against particle A, and obviously the force pulling the particle B towards the ground is 0.8 G. Alright, so these are the things that we're told. Right, so the first thing, we're told that the system is released from rest. Alright, and as we found out yesterday, we know that because this is obviously a greater mass, it's going to get pulled towards the ground. And this force over here is not going to stop it hitting the ground because it's not great enough. Alright, so what we need to do is, first thing it's asked us to do is find out the value of A. Now, from what we were talking about yesterday, we were talking about those pulleys that go up and down like that. In a normal pulley system, we're going to have to solve it. We're going to have to make up 2 different equations, and then we're going to solve them simultaneously. Alright, so question A says find out the acceleration in the system. Alright, so from the perspective of particle A, acceleration is going that way, and so is the tension away from particle A. Therefore, T must be at the front, minus force working against it, which is 0.08 G, and we know that that is equal to 0.4 lots of the acceleration. Alright, if we look at it from the perspective of B, acceleration is going down, but the tension away from particle B is going that way. So we know that T is going to be negative, and we know that the force working in the same direction as acceleration is 0.8 G, and that equals 0.8 A. Alright, we're happy with that. That's the sort of thing we were doing on Monday afternoon. Alright, we'll label that equation 1, equation 2. And if we know that if we add the 2 together, that's going to cancel out the t's, which is fantastic. It just leaves the variable a. Add these 2 together, we're going to get 0.72 G is equal to 1.2 A, which means that A must equal 0.72 G divided by 1.2, and that's going to leave us with a value for A equal to 0.6 G. Obviously, if you put that into your calculator, you get 5.88, and obviously that's going to be meters per second per second. Alright, so that's what you're looking for in part A.